Miss who's hands طلع
محمد. Dana, pay attention please to your mic. All right, guys. Where are the rest? Tell them to join quickly. Tell the rest to join quickly, please. I want you to open page 85. We're going to do question number 2 together now. Page 85.
Miss,
Okay.
it's 95. 95.
85, dear.
Yeah, okay.
All right. Okay, in question number 2, as we said, Sarah found her little brother playing with magnets. He was banging them together. Write a safe handling rule that Sarah should tell her little brother. So as Liane said, and as we said now, he should bring the magnets closer to each other slowly, or you can write, don't bang the magnets together, okay? Or don't drop the magnets. Any of those answers is correct. Now, the last thing, Sarah's mother asked her to store the magnets away. You can
Miss,
write, yes.
I wrote don't bang the magnets like you said.
All
but
right.
but can't it be hold the magnet from the right place?
There is no actually right place to hold the magnet from.
Because if we put our hands from the poles and we put a magnet to attract to another magnet, so it can harm our hands.
It's not one of the safe handling things. The kind of harm is not that big if you handle it or you hold it from a wrong place, as you said. But if you want to write it, no, I prefer that you write the more obvious things. Like what? Like don't bang them against each other, don't drop them, stuff like that. Okay?
Okay.
The last thing is about the storage. So if you want to write a magnetic keeper, this is fine. If you write, don't put them in wet places. Don't put the magnets in wet or dusty places. Right?
Yes, I wrote something different.
What did you write, dear?
I wrote don't store them away, it will affect its magnetism.
Don't store them away, it will affect their magnetism. And I don't, just give me 1 second, guys. Someone is talking, so please wait for me to answer them. So Hayla, the statement doesn't make sense there, because if you stored it away, if you stored them away in with a magnetic keeper and this place is not wet or dusty, then it's totally fine. You did not specify what is the problem. Storing them away is not a problem, but how you store them is the problem. So if you want to write something more accurate, you write don't store them without a magnetic keeper, or don't store them in wet or dusty places, because they are going to lose their magnetic effect. But don't store them away because they will lose their magnetic force. That doesn't make sense, honey. Okay. Yes, Dana, did you want something?
Yeah, I wanted to say, why shouldn't we place them next to wet places?
I just said in the safe handling and storage of the magnet, because this way it's going to lose its magnetic force. Okay. Yes, Habiba,
Nothing, Beast.
did you want to say something?
I was just asking, can I go to get the eraser, but I got it.
Okay, all right. Now I want you guys to open page 83. We need to complete the choose question in page 83. All right. The pushing or pulling force of a magnet is, the pushing and pulling force. Who would like to answer? Who would like to answer? Will the rest join us? Would you please send them in your WhatsApp group or whatever to join? Because we have another session. Did they forget about it or what? Yes, Habiba. Answer the question. The pushing or pulling force of a magnet is? Strongest in the middle of the magnet, strongest at the ends of the magnet, or the same way through the whole magnet?
Strongest at the ends of the magnet.
Yes, strongest at the ends of the magnet. Yes, strongest at the ends of the magnet. Very good. All right. Next, question number 5. Which two metals will be attracted by a magnet? Yes, Dana.
Miss, what is that page?
This is page 83.
Iron and steel.
Are you Dana? Are you Dana?
No.
It's Nadim or Ayman, I don't know.
Not Ayman. This is Nadim.
No,
Sorry,
I'm Nadim.
The one who answered. Who answered?
Me. I heard you saying Nadim.
Okay. Dana?
Yes.
When two magnets repel each other, they?
Push away from each other.
When two magnets repel each other, they push away from each other, pull towards each other, or neither push or nor pull? I can't hear you, Dana. What did you say?
A. Push away from each other.
Yes, push away from each other. Thank you, Dana. And the last question is, when two magnets attract each other, they Adam, can you answer this one?
Yes.
When two magnets attract each other, they do what?
They pull towards each other.
Yes, they pull towards each other. They pull towards each other. All right, now the last page, page 84 in the magnetic or the magnetism lesson, page 84. Okay. This is about the uses of the magnets. You just have to read the lines and you have to guess which device are we talking about. The first one, inside this building is an extremely big magnet that helps to make electricity. Inside a building, which one of those is a building? Which one of the pictures is a building? Yes, Jaida.
Power station.
Power station, very good. So the first thing is the power station. Of course, there is something wrong in the numbering of the statements. So pay attention. This is the power station. All right. Thank you, Jaid. The next one is safe. Inside the device, electricity makes a tiny magnet vibrate or shake. The vibrations create sounds.
Speakers.
Speakers, very good. Speakers. Okay, number 3. It's written 2, but it's number 3. Inside this tool is an electric motor. Motors use electricity to make magnets that spin around very quickly. Pay attention, guys, and read number 4 also. This machine uses an electric motor to spin the washing. So which one is which? Yes, Habiba. Number 3 is which one?
Number 3 it is the electric drill.
Yes, number 3 is electric drill. So this leaves us with number 4 and the washing machine. All right. Now we're done with all our worksheets. The reading worksheets, guys, which are pages 37 and 93, we're going to finish them after finishing the revision. Okay, we're going to write them after finishing the revision. As I told you, you're going to find the extra practice worksheet that I will upload for you today after the school day. Yes, Muhammad, you can go. All right, now we are going to start answering the final revision sheets, which is found in your resource pack, page 96. So please, I want you to open page 96. Page 96.
Miss, page 96 is white.
The other page,
I know the
96.
other page.
There are two 96 pages. Yeah.
Yeah.
All right. So here we go. This is page 96. Question number 1 says, Abdul has some stacking masses. He puts one mass on the stacking tower. He uses a force meter to pull the tower. Abdul has some stacking masses. He puts one mass on the stacking tower. He uses a force meter to pull the tower. There is a force on the tower from the force meter. Okay, draw an arrow on the picture below to show the direction of this force. Okay, we want the force that Abdul is pulling with. Okay, not in the other direction, not the one that is trying to pull back. No, we want the direction of the movement. We want the direction of the movement. So which direction will it be? Is it towards Abdul's hand or towards the stacking force or the stacking tower? Yes, Jaida?
Yes, miss.
We want to draw an arrow on the picture below to show the direction of the movement.
Okay. So
He's pulling, so he's pulling in which way? To the left or to the right? Huh?
to the left.
To the left, exactly. So you're going to draw an arrow this way. He is pulling to the left. All right. The next question. I need to take the attendance because I feel like there is a lot of people who did not join us now. Adam? Adam?
Oh, yes, yes.
Alia? Alia is not here, right? All right. Ayman is here. Bilal? Bilal?
Yes.
Dana?
Yes. Yes.
Habiba? Jaida?
Yes.
Layan?
Yes, miss.
Malik? Mu'mina? Muhammad Ahmad? He said he's going to the bathroom. Are you back, Muhammad? Okay, Muhammad. Muhammad. He's not here. Muhammad, are you there? Muhammad Sharnubi.
Muhammad is in the toilet.
Okay, dear. All right. Nadim. Nadim.
Yes, miss.
Omar. Omar is not here. Saif.
Yes, miss.
Yes, I'm here.
How are you? Who said I'm here?
Miss, I came.
Okay, Muhammad. It's all right, dear. All right. So Hayla
Yes, miss.
and Tayyim. Tayyim is not here. Okay. Okay, Muhammad. Let's continue. The next question is question B. Question B. It says, Abdul measures the force needed to pull the tower. He notes the force meter reading each time he adds a mass to the tower. So what did he do? He has the stacking tower. He keeps adding masses to it and pull it with the force meter. And each time he adds more masses, he pulls with the force meter and he writes the reading of the force meter, how much he exerted an effort or made force in order to pull the stacking tower when he adds more masses to it. And those are the readings right under the towers. When there was only one mass, he pulled the stacking tower with a force of 0.3 newtons. When there were two masses, he pulled the stacking tower with a force of 0.45 newtons. And when he pulled the stacking tower with three masses in it, the force meter read 0.6 newtons. And when he added four when he added four masses, it was 0.75. And when he added those are five masses, he pulled them with a force of 0.9 newtons. Okay, describe what Abdul's notes tell him about the number of the masses and the size of the force needed to pull them. I want a relation. I want a relation between those two. I want a relation between those two. When what increases, what will increase or decrease? Do you understand? Layan, can you answer this one?
Yes, miss.
Yes, dear. So I want the relation between the number of the masses and the size of the force he is pulling with.
So
When he adds What? More what?
When he adds more force, or when he pulls more, the more the weight is like.
No. The other way around, dear. When he adds
okay.
what to the stacking tower? When he increases the number of what?
The number of masses.
Yes, increase means makes it more. When he increases the number of the masses, as you can see, first it was only 1, then it became 2, and then 3, and then 4, and then 5. What will happen to the size of the force? Look at the readings now, below the stacking tower.
Okay, Miss.
Will it also increase or will it decrease?
It all increases.
Yes, so when he adds or when he increases the number of masses, when he makes the number of masses more, the size of the force also is going to become more. As you can see, when there were only 1 mass, the force was 0.3. But when he added 5 masses, the force became 0.9. So this means that when he increases the number of masses, the size of the force will also increase. All right, thank you, Layan. The rest of the class, do you understand?
Yes.
All right. When? So I'm just going to write the answer. When he increases the number of masses, the size of the force will increase. Increase means becomes more. Decrease means becomes less. Okay? Increase means becomes more. All right. When you finish, tell me please, so that we can go to page 97. Are you done, guys?
Yes, Miss. I finished.
No.
All right, please hurry up.
Finish.
All right. Now let's move to page 97. Let's move to page 97. In page 97, Abdul puts his results into this table, but he makes a mistake. What is the mistake in Abdul's table? Huh? What is the mistake in Abdul's table? I want you to compare the picture in page 97 in page 96 to the table that he made in page 97. Huh? What the mistake that he made? Yes, Jaida.
The number of mass.
No, the number of mass is correct. I want you to compare the picture in page 96 to the table that he made. Yes, safe.
That the reading of the force meter is not correct.
Yes, the reading of the force meter, he flipped it. Yes, he flipped it. It was supposed to be number 1 is 0.3, number 2 is 0.45, but he made it the other way around. So he flipped the force meter reading. He flipped the force meter reading.
I finished.
Okay.
Miss, you wrote force meter.
Okay, I will make it correct. Sorry. All right.
Miss finished.
All right, let's do D. Question D.
Yes, I finished.
All right, dear. Abdul notices his mistake. He corrects his table. Then he says, I wonder if I made any mistakes when I did my test. What should he do to check if he made any mistakes in his test? We said that this type of question has only one answer. This kind of question has only one answer. He should do what with the test? Yes, Habiba.
He will make the test again.
Yes, he should repeat the test. He should repeat the test. Repeat the test. If you want to add several times, it's fine. All right, very good. Now we're going to move to page 98. Omar, did you join us?
Finished, Miss.
All right,
Finished.
Omar. Omar, did you join us? All right. Now let's go to page 98. Question number 2 says, some children are riding skateboards. It is easy to get hurt riding a skateboard. Look at the picture below. List 2 pieces of safety equipment that the children have used. 2 pieces of safety equipment. What did they do to make themselves safe while they are riding the skateboards? Yes, Suhaila.
Yes, Miss.
What? Give me 2 of the safety equipments that they put on in order to make themselves safe while they are riding the skateboards. Look at the picture, dear. What did they wear?
They wear the safety tools of the
Yes.
skating.
What are they? Give me 2 of them. The names of 2 of them. What is the thing on their head? They put on helmets, right?
Helmets.
Yes.
Helmets.
Helmets. And what about those things on their knees? They're called knee
I
what?
know them, but I don't remember its
Knee
name.
pads. Okay.
Knee pads.
Knee pads. Yes. Helmets and knee pads.
Helmets and knee pads.
All right. All right. The next question is, Jane and Lois are facing in the same direction. Both of them are riding in the same direction. Did you finish? Should I erase this?
No, Miss.
Okay, please make it quick. Jane and Lois are facing in the same direction. They are on level ground and they are not moving. Jane gently pushes Lois on his skateboard. He moves forwards. As Lois moves, Jane also moves. Yes. You finished? Should I erase?
Yes.
Yes.
Okay, here we go. So again, Jane and Lois are facing in the same direction. They are on level ground and they are not moving. So they are only standing on the skateboards and they're not moving yet. Jane gently pushes Lois on his skateboard. She pushes him on his skateboard. He moves forwards. As Lewis moves, Jane also moves. In which direction do Jane and her skateboard move when she pushes Lewis? Huh. This is something. Yeah. What?
I wanna answer.
Okay. This is something that you saw in your real life. If you
Yeah.
are on wheels and someone else is on the wheels and you push this person forward, how will you move? Yes, Ayman.
Backwards.
Backwards. Yes, this is true. You're going to move backwards because it's like something that your body is reacting to. Okay. And by the way, this is something that you are going to learn about later. It's called inertia. But you don't have to really, you just have to answer this with your common sense. But I'm just telling you that it has a name that you're going to learn about later in the upcoming years. Okay? All right, very good. Now, please open page. What?
Do you know that I have a skateboard and I am learning, not like learning in somewhere like my dad was.
All right, nice. Very nice. Have fun with it. Page 99. Jane and Lewis go back to the same starting places. Jane gives Lewis a bigger push on his skateboard. They both move faster this time. What happens to the distance that Lewis travels on the second push compared to the first push? Huh? Yes. Yes, Muhammad. Can you tell me?
Yes.
Okay, now Jane pushed Lewis a bigger push. What will happen to the distance that Lewis will travel this time?
Longer.
It's going to be longer than the first push. Yes, very good. Thank you so much. The distance he will move a longer distance. The next question is what happens to the distance that Jane travels on the second push compared to the first push? Huh? Yes, Lyanne.
She's going to go more backwards.
Yes, so she will move backwards a longer distance too. Thank you. She will move backwards a longer distance too. All right. Are you done?
No.
Okay, please make it quick.
Finished.
All right.
Finished.
Finished, miss.
Okay. All right. Make it quick, please. Make it quick, please.
I want to answer number D.
All right, dear. You're Jaida or Suhaila?
Sahila.
Okay, Suhaila.
Finish.
Okay. All right, Suhaila, do D. Do question D. Dave goes over a jump
On his
just
skateboard.
give me 1 second.
When
I'm sorry, give me 1 second. Because people from another class keeps getting into this class. Okay, Dave goes over a jump on his skateboard. When he jumps, he stays in the air for a short time. What force makes him return to the ground?
gravity.
Gravity, very good. It is gravity. All right. Now, page
I'm
100.
finished.
Okay, page 100. We have 3 minutes left, so we can do page 100. Page
Did
100.
we finish the book yet?
What?
Did we finish the book?
I'll have 3 pages or 4.
We will finish the book. Do you want to know what will happen next?
Yeah.
Yes.
Yes, after finishing that, we are going to, as I told you, re-answer your quizzes. And then I'm going to make you a PowerPoint for revision. And we also are going to answer the reading homework
When
pages.
is the exam? When is
Next
the exam?
Sunday, dear, next Sunday. Question number 3 says, David,
Miss,
yes.
I think I understand why I think I understand why when Jane is pushing Luis, Luis is going
Forward and
and
she's going
backward
backwards.
because she isn't stronger than him, I think. So so she's when she's pushing him, she can't stay in her place.
No, it's because she has wheels under her legs. If she is standing on the ground, if she's
So
standing
she
on the
will go
ground,
back.
she will not go back, yes.
Yeah.
But miss, the wheels are steady.
And how will they stay steady? I don't understand. Have you been on wheels before?
Oh,
Yeah.
And when you push someone, you stay where you are?
I didn't push someone.
Then try doing it. Of course, don't push someone like to make
it's
them
not
fall.
steady.
They are steady, so you have like brakes in your skateboards. I don't get it. You have
No,
like
they are not steady.
they are not steady. Yes.
They won't be steady.
Yeah.
Not okay.
Okay. Question number 4 quickly. David, or question 3, number 4. David put 2 bars of iron close to each other. There was no magnetic force between them. David recorded the results as shown below. So he has a bar of iron and it has no 2 bars of irons and no magnetic force. Nothing happened when he put 2 bars of iron next to each other. Now, David did 3 other tests. Tick the correct box to show the result for each test. We have 2 of them here, okay? So let's take Bilal. Are you there, Bilal?
I'm there.
Bilal, you're here?
Yes.
Okay. So when he puts a bar of magnet next to a bar of copper, what will happen?
It will repel.
A bar of copper is a magnetic force, is a magnetic material.
No.
They will not repel, dear. Nothing will happen. They will not attract and they will not repel. No magnetic force will be there because it will not react against copper at all. The magnet considers the copper as air. It's not, it doesn't even exist. So it will not repel and it will not attract. Repelling is a force because when you bring 2 magnets together and both of them are facing similar poles, you will feel like they are pushing against each other. But in this case, you will not feel anything. All right. I will do the last one before I go. Now you have a bar of magnet and a bar of iron. So in this case, they are going to attract because the bar of iron is a magnetic material. So of course, it's going to be attracted.
The other session started.
Yes, I will end the session now. All right. I'll see you next time, guys.
Bye.
Bye.
Bye.